I'm going to talk about the liver and the pancreas, specifically what you colored on pages 142 and 143 in the anatomy coloring book. So the liver is a large organ, approximately 1.5 kilograms or a little over 3 pounds in the upper right quadrant of the abdomen, just inferior to the diaphragm. So the diaphragm would be here, and to the left of the stomach. So the stomach would be over here. The coronary ligament, so that's what I've represented in sort of this light green color here, holds the liver against the diaphragm, and the right and left lobes of the liver are separated by what's called the phalliciform ligament, which I've colored in sort of this turquoise color here. These ligaments are not related to skeletal ligaments. They are folds in the peritoneal membrane. The phalliciform ligament secures the liver to the posterior body wall. Now, the liver is functionally divided into 8 segments by the distribution of blood vessels. 20% of the blood that comes to the liver is oxygenated, so that's represented here by the pink arrows. So that's coming through the hepatic artery. And 80% is nutrient-rich deoxygenated blood that arrives via the hepatic portal vein. The blood then travels through hepatic sinusoids, through these lobules, to a central vein, and then to the inferior vena cava, and then to the right atrium of the heart. Now, the liver is kind of like the multi-tool of the body. It carries out many functions. Of those functions are carbohydrate metabolism, the production and secretion of bile for lipid digestion, the synthesis of amino acids for clotting, lipid metabolism and cholesterol synthesis, breaking down insulin and other hormones, breaking down bilirubin from red blood cells to facilitate bile excretion, converting ammonia to urea, storing vitamins and minerals, and probably its most famous function, detoxifying the blood by breaking down toxic substances. So now, where all this takes place. It happens in what are called hepatic lobules, and these are considered the functional units of the liver. According to the model, each lobule is like a hexagon shape. At its center is a central vein. Radiating out are these sinusoids and rows of what are called hepatocytes. So this is where all that work is happening. Located at the corner is what's called the portal triad. So in pink is represented an artery, a hepatic artery. In green is a bile duct, and in sort of the violet color is a tributary to a hepatic vein. So now this model is based on a pig, but in humans the lobules are less defined, but this is the general idea. Now, carbohydrate metabolism. Yeah, I wasn't supposed to be there yet because we got to talk about the pancreas first. Where the pancreas is a lobulated gland, and its cells are divided into 2 functional groups, exocrine and endocrine cells. The exocrine cells secrete enzymes that aid in food digestion. So the enzymes reach the small intestine via ducts. So all these little like branch looking things. So these ducts run into this channel here, which comes down and joins the bile duct. And together they go out to the duodenum via the major duodenal padilla or padilla. And that's where they leave. Anyhow, this picture here shows the organization of the liver, the gallbladder, and the pancreas, and how the bile duct, or how the gallbladder as well, how all this plumbing essentially is all connected to lead into the small intestine here. Now, the endocrine cells secrete hormones into the bloodstream. So the endocrine system from the pancreas secrete hormones directly into the bloodstream to control blood sugar. And now I get to talk about carbohydrate metabolism. So if I eat a bunch of cookies, I get really high blood sugar. And when I do that, that promotes insulin release. The insulin comes from the pancreas and it gets sent out into the blood. The insulin then enables cells to use the glucose for cellular respiration. And any excess glucose that my cells don't need ends up going to the liver and synthesized and stored as glycogen. And once the liver takes up that glucose in the form of glycogen, then that lowers my blood sugar. Now, if I go on a long bike ride and I didn't eat enough before I left and I don't have enough energy, like enough fuel, I have this energy reserve of glycogen. And that low blood sugar promotes glycagon release from the pancreas. So that's the other hormone that the pancreas creates. And that glycagon gets sent to the liver to then break down the glycogen to turn it back into glucose. That glucose that gets broken down from the glycogen gets sent back out into the blood to raise my blood sugar so that now it can promote insulin release so that my cells can use that glucose. Now, unused glycogen will get converted to triglycerides, which can result in a fatty liver. So it's important to stay active and not eat too much sugar.